喂喂喂喂喂喂，不然你讲好一切。喂喂喂，真假的？我刚测试，真的假的？你刚那时候换一下，好，应该是全部都开哦。喂喂喂 ，test test test test。对，阿周有听到吗？阿周有听到吗？在门口。喂喂喂，测试测试，喂喂喂，喂，是用这个吧？什么意思？他就在这，他就用这个上课，然后点这个上课表。 test test test。喂，测试测试测试。我去隔壁台问。OK。好，那是那个就是说那个这些写推荐信啊，这种。OK。Okay, let's start today's introduction. Today we're gonna do some experiments about the rectifying circuits, which we have already introduced in the electronic class. And this is the circuits related about the diodes. We already know that the half wave and full wave and the bridge rectifier in the class. So maybe today we're gonna do some experiments about this, and we also trying to know about the voltage doubler and some parameters meaning about the circuits. The reason we trying to use the rectifying circuits is that sometimes when we apply this to the some different kind of circuits, we have to use the DC voltage, but the power supply is sometimes just the AC voltage. You will change the polarity on different times. So we have to use these circuits to help us achieve the DC source. So we can see the figure on the bottom of this page that when the power companies supply the AC, and we have to use the transformer to raise or lower down the voltage of the AC voltage. But the most important thing is that here that we have to use the rectifying circuits to change the AC into a DC source, and the DC source after we have inputted into the circuits is not very stable. It has some ripple, and so we have to use the some voltage regulation to use to let the ripple become a stable DC source, and we can output it into the load resistance. And here are the meanings of some wave that we have used in these experiments. That the maximum value, which means the peak value of this wave, and the peak to peak value. Peak to peak value is means to the upper one, to the lower one, and the RMS value, which is the Roomy square value that we have already learned uh, in the electronic class, and there is another average value and different meanings that we have to uh, know that this meaning is different. Um, the experiment we have tested already in the last week arrangement is that we already know the diet has different characteristics. That if we add the uh, different polarity on its uh, two sides, and the current will flow through, or the circuits will be cut off in the different operation. And as to the first rectifying circuits, that the half wave rectifier circuits that we use a diode and low resistance, and we the different polarity of the input waveform will let the diodes conduct or cut off in the positive or the negative voltage. So as we can see, the output voltage is the voltage across the load resistance that we have waveform like this. It doesn't have the negative voltage when the waveform is being handled by these circuits, and it has only positive and zero voltage, as we can see in the right of this figure. Okay, and as to the full wave rectifier circuits, full wave and half wave, they have difference. The full wave, we use the circuits with two diodes, and these two diodes is connected to the different part of the circuits. And when we input the same sine wave into these circuits, and it will make these two different diodes D1 and D2 conduct or cut off, and they will not conduct at the same time. They will conduct or cut off in a different polarity of the input waveform. So we also measure the output waveform of this sine wave, and as we can see that in the negative input voltage, it will become a positive voltage, and as we call this full wave rectifying circuits. And the third one is the bridge rectifier circuits. The bridge rectifier circuits, we have to use four different diodes in these circuits. And as we can see, and we already learned in the electronic class, that the effect of these rectifying circuits is similar to the full wave that we have uh, introduced before the previous pages. And so the only different thing is that when we conduct these circuits, and it will such as D1 and D2 will conduct at the same time, or D3 and D4, and at the same time D1 and D2 will be cut off. So it will only have two diodes conduct one time. So the output waveform will be lower than the full wave rectifier circuits, because there are two diodes conduct simultaneously. So I remember that there is okay. And here is the circuits that we call it the peak rectifier. The peak rectifier means that when we use these circuits to when we charge this capacitor into its peak value, and we hope that it will be stable at a constant value. However, that there's always a load resistance. that in parallel with this capacitor, so it will discharge some charges to the low resistance. So the actual waveform of this peak rectifier will be like this, that it will discharge in a period of this time. And we call it ripple because it's not very stable. So we have to choose the correct value and design the circuits when to see what we want to use and apply. That if the capacitor is bigger or smaller, the ripple will have different waveform. And so if we combine the peak rectifier and the three rectifier circuits we have learned before, we can see that the ripple have different shape as the right side of this figure. There we can see the half wave, full wave, and the bridge rectifier. You can see the magnitude of the bridge rectifier is really smaller than the full wave rectifier because there are two diodes conduct at the same time. So this is the ripple we have talked about before. And here are the voltage doubler. The voltage doubler, we have different type of voltage doubler. And basically the voltage doubler is consists of peak rectifier and clamping circuits. It's the combination of these two rectifying circuits because that we can see the original input AC voltage is here. And we have to the peak rectifier and use it to achieve the constant value by a ripple waveform. And we clamp this voltage into a higher one, into a 2 times of the original value. So we can see that the ripple is higher than the one before. So we have 2 times voltage. So we call it the voltage doubler. It's the double the original value of the voltage. And here's the plastic type that I have already said that is combined with clamping circuits and peak rectifier. So we can see that the output circuits or output waveform is just like this. And the reason I say that the voltage doubler has different kind of type because that we sometimes we have to use and change it into a 3 times voltage or several times of this voltage doubler. So we have to change the arrangement of the circuits as we can see in the top of this page. The 3 times voltage doubler is a little bit different from the one we introduced, the 2 times voltage doubler. And the bottom one is the multiple voltage doubler because we have to connect the probe into the different position so we can achieve the multiple voltage doubler. And here are some definition about the related to the rectifying circuits. So today we're gonna learn about the some of these circuits, and we're trying to watch and observe the waveform after we input this into the these rectifying circuits. So let's start today's experiment. Okay. We can go to the lab and start today's experiment.